Higher course section 9.2 page 103 standard index form, or just standard form. The reason it's here is because standard form is about playing with very large numbers, and we can express it as simple powers of 10. You'll see what I mean in a minute. Besides, this repeats unit 1 anyway, except there's no jolly calculator to help us, and you'll see why it could be a little bit of a problem later. I did say you'd be dealing with very large numbers with standard form. Of course, it can be very small numbers like 0.0000073, and there must be a kind of way of writing that in a way that's pleasing to the eye and also saves ink. And in fact, there is, and we'll look at some of that. I just want to remind you of a couple of little bits and pieces. Now, it says question 1: write the following ordinary numbers into standard index form. So standard form. Here we go. 4200, 4200. That means 4.2 times 10 to the power of 1, 2, 3. I'm essentially multiplying by 1,000, that's what I'm doing, and 1,000 is 10 to the power of 3. It's in this unit because we're playing with powers still. And that's one example there. Please note, it is not equal to 42 times 10 to the power of 2. Mathematically they're the same, but standard index form requires a single integer before the decimal point and the figures following kick in. So don't ever do that. I'm going to leave it there, put a box around the correct one. Remember, that's right, that's wrong. Back to black. I did say we can do with very little numbers as well. Look at this one. 0.0000 1, 2, 3, 4 00178. I'm only going to give you one example because we've done it before. Equals, well, follow the rules. 1.78 times 10 to the power of. Now start here, right there. Okay, go back 1, 2, 3, 4, 5, 6, 7. 10 to the power of negative 7, and that's shorthand for all these little zeros there. All right. So that is that, and that is very, very pretty indeed. Much kinder than having to write all those zeros out. And imagine if there was like 20 odd zeros there, we'd be looking at powers of minus 19 or minus 20, depending on the number itself. Don't want to go down that route. Right, that's that done. Now, converting index form numbers into ordinary numbers just works the other way. I've got here 7.005 times 10 to the power of 3. That means just go bounce, bounce, bounce. 7,005, essentially multiplying by 1,000. That's correct. Let's just do one of these that go backwards, shall we? 4.75 times 10 to the power of minus 4. That means go back that way 4 spaces. Now, 475. Go back once, done. Twice, 3 times, 4 times. Put a spot there. So it's 0.000475. Let's just check. 1, 2, 3, 4. Yep, it's right. That'll do. Now over the other page we get some more interesting arrangements where you have to calculate numbers given to you in standard form, and you usually leave it in standard form. But let's have a look. Work out the following. Some of these are really easy. It becomes grade A quite quickly, but honestly I don't see where, because in older books this is grade B rated. Anyway, 4 times 10 to the power of 4 in brackets, so not needed, times 2 times 10 to the power of 7. Now check it out. 4 times 10 to the power of 4 times 2 times 10 to the power of 7. We don't need the bracket there at all. Look at this. 4 times 2, 8. Times 10 to the power of, remember the rules? 4 plus 7, 11. And I have jolly well done it. It doesn't say leave it in standard form, it says work it out. Oh, alright, so you want 8 followed by 11 noughts, do you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Don't waste my time. The whole point of standard form is to leave it like that. So I'm now going to move on to the next one. I don't know, just miss a couple out, because it's going to get boring. 5 times 10 to the power of 5 in a bracket, not required, times 3 times 10 to the power of 9. Here I go. 5 times 3, 15, times 10 to the power of 5 plus 9, 14. Now, pause for reflection. That is not allowed as standard form. It's okay as it stands. However, it insists on being 1.5. Remember, just one integer there, times 10 to the power of, well, if I've made it go backwards 1 and it wants to go forwards 14 spaces, I've got to pay him back. So pay back the power, as I like to say. Okay, this is my speech there. You don't see this written down anywhere. I'm going to say pay back the power. So when you hear me say that in class, it means up it by 1 or 2 or how many spaces you need to go. Alright, so it's 1.5 times 10 to the power of 15. I'm not going to write out 15 followed by 14 noughts. I'm just not going to, demolish my video like that. How about this one? 1.5 times 10 to the power of 7 squared. Now that does deserve a bracket. What does that mean on the earth? It means 1.5 times 10 to the power of 7 times himself. That's what squared means. 1.5 times 10 to the power of 7. Now, no calculator, but 1.5 times 1.5 is 2.25. And I'll tell you why, because I know, and I've committed to memory, that 15 times 15 is 225. Learn that one. Hence 2.25. And now we're free to just add the powers of 10. 7 and 7 is 14. And that's all there is to it. Then we've got some dodgy little dividey ones here. Well, I'm going to do them, and I'm not going to be scared of them. Yes, I am a little bit scared. Let me just do this one here. It's 3.9, actually looks quite kind, times 10 to the power of 5 divided by 1.3 times 10 to the power of 8. It looks ever so frightening until you realise that 13 goes into 39 3 times. Therefore, 1.3 will go into 3.9 3 times. Answer, that's the next step. Power of 5 upstairs divided by 10 to the power of 8 downstairs. Well, we've got to obey it. Got to do 5 take away 8, 10 to the power of minus 3. 5 minus 8 is minus 3. It doesn't say standard form, but that's fine as it is. If you want to change it into a proper number, you'll go back 3 spaces. 0.003. So that, my friend, is that. 1, 2, 3, it's correct. I'm happy with that. Turn over. Let's do one more of the dodgy ones. So 2.2 times 10 to the power of 1, in other words, times 10, and then I'll divide that by 5.5 times, come on, 10 to the power of minus 6. Well, as you can see, 22 and 55, we're looking at 11s, aren't we? So let's just put in some 1.1s in there. So 1.1 in there goes twice, 1.1 in there goes 5 times. Is that alright? So that's basically 2/5. Easy. Right, upstairs I've got 10 to the power of ordinary 1, in other words 10, times 10 to the power of minus 6. Now, 2 divided by 5 is 0.4, because 2 over 5 is 4 over 10, 0.4. This is a high level, grade A type stuff. I'd say B really. And therefore we can be able to handle that in this context. Times, well, let's do the powers, 1 minus 6. Let me write it for you. 1 take away minus 6, and that means 7. Therefore, 10 to the power of 7. If I want to write it in standard form, I've got to go 4 times. Now, you're not paying back the power this time. You're taking one off, because you're actually going that way. And therefore, one of these gets used up. 10 to the power of 6. And if they want it in proper stupid numbers, then it's 4 followed by 6 zeros. 4 million. Wouldn't it be nice if it was pounds? We can all share it and have a party. Right, so there you go, 4 million. That is that. What's next? Can't be bothered with you. Now, question 6 is mixed questions, really. They give you values for P and Q. Then you've got to work out P times Q, P divided by Q, etc., etc. I don't know, I'll randomly pick one. What looks hard? I think I'll do a plussy one. I want to do P plus Q. I'm told that P is worth 4 times 10 to the power of 2. I'm told that Q has a value of 2 times 10 to the minus 1. I'm going to go for an addition one. I actually want to do that. So that means P equals that, which is going to be 400, and Q is going to be 2 times 10 to the power of minus 1, in other words 0.2, and I've got to add these little things. Oh, are you you're kidding, aren't you? Anyway, no, they're not kidding. Let's do it. 400.2. Isn't that lovely? Not really. It's an ugly number. Let me do P minus Q. Alright, go on then. I've already worked out P and Q, so I've now got to do 400 minus 0.2. I've got roughly 399.8. Very unsatisfying. I can't be bothered with P squared. It's too easy. Right, I'm going to stop. I'm going to stop. Oh, I've just seen one right at the bottom of the page that looks really challenging for one's brain. Now I want to do it because I don't usually do these brain teaser questions, but I'm going to do this one because it shows something that could lead some of you into a common error. Now look at this. I've got this scenario here. I've got 4 times 10 to the power of 4 plus, not multiplying, plus 2 times 10 to the power of 4. Now apparently one child who shall be nameless says this. That equals 6 times 10 to the power of 4. Brian, he's the other guy who shall remain nameless, who I've just named, says this. 4 times 10 to the power of 4 plus 2 times 10 to the power of 4 is 6 times 10 to the power of 8. They can't both be right. Let's do this. Right, let's actually work out the sum. 4 times 10 to the power of 4, let's do the top one. We'll do that one right here. That means 4, 0, 0, 0, 0. Fair enough? And 2 times 10 to the power of 4 means 2, 0, 0, 0, 0. And I'm adding, and that makes 6, 0, 0, 0, 0. And that is in fact 6 times 10 to the power of 4. So what this little chap has done, he's added the 4 and the 2 to make 6, but then added the powers. But you only add the powers when you multiply. So therefore, this one is correct and this one is wrong. And I felt I had to show you why it was correct. And I'm now going to stop because that's as far as standard form goes up to grade B, although claiming grade A for itself. Unjustified, I think. Either way, you nail it and get your biggest grade possible.